last week, okay? Lesson 6, 7, B, or A. What was the equation that you came up with? Because remember, you were using the calculator in class, and I had you come up with the line of best fit on the calculator first, and then you took this home. So what was the equation you came up with for the line of best fit? This was the question number 2. Nadeja.
Y equals 8.9x plus 572.81.
572 and what?
8 tenths.
And 8/10, okay? So what did the slope represent? First of all, which one of these numbers is the slope in this case? Which one of these numbers, Kaylee?
Negative 8 and 9 tenths.
Negative 8 and 9/10. What does that represent in the case of this word problem? Okay, I know that negative 8 and 9/10, if we write it as a fraction, that tells you how to move when you graph it. But what does it represent in this word problem? What does this represent in the word problem? So look back at what it's asking. Negative 8 and 9/10. What is that representing? Milo, what do you think?
Representing how much the winning time improves each year.
Okay, and why do you say improved?
Because it's the winning team, so it has to get better each year.
Okay, but this negative is throwing me off. Why would negative mean they improved? Oh, what's that negative representing in this case?
How
Bless you. Thank you.
much it goes down?
What goes down?
Time.
The time. Okay, why is the time going down an improvement instead of a bad thing?
Because you want it to be done before like a long time, so it goes down.
Awesome. Improving time means you are taking time off of your total amount of time you're racing, okay? So if we're going down this amount, that means the time is actually improving, okay? So what is this? The time is negative 8 and 9/10 what? What are our units for that slope? What are we talking about here? We are decreasing by 8 and 9/10 what? Kayla?
Minutes.
Minutes per
Round.
per what?
Round.
I didn't round. What does that mean? Round of
Oh,
what?
sorry. Per round.
Per what?
I don't know. Per year.
Per year. Awesome. Okay. Our slope is the change in our y's, which is the time, over the change in our x's, which is the years. Yes, James?
Wouldn't it be per race because there were 2 races in one of the years?
That's true. Technically, it would be per race, but we're doing. You're right. So it would be, since there were 2 in 1982, it would be per race. But most of the time, it's going to be years, since that's how we're measuring it. Okay. Very good. Any questions on the slope? Okay. How could we predict the winning time for the year 2014? So we have this line of best fit. How could we predict the amount of time it will take the winner to run it in the year 2014? So this year when they do the race. How can we predict that? So look at what we have. We know the year is 2014. What information can we use to predict the winning time? What do you think? Look at what you've done for other years, and what would you have to do to predict? You don't have to actually do the work, just tell me what you would do. Marnie, what do you think?
Like 2014 and the X and solve the equation.
You are almost perfect. I like that you're looking at 2014. I like that you're substituting it in for X, but you're not going to actually put this number in for X. Can anybody help her out and look at what, oh, you know, okay.
14.
Not just 14. Call on somebody to help you out. What number are you going to put in? Jasmine.
We're going to take, we'll put in the number, the amount of years since the first race.
Which was when?
Um,
We're not the first first race, but the first one we have. What was the first year you had on your paper? Very good, 1980. Okay, so we want to know how many years since 1980. So Marnie, back to you. What number would we put in? How far away is 2014 from 1980? How many years? How many years to 2000? Not quite. 1980. How many years was that until the year 2000? 34 from to 2000 or 2014? Very good. So it's 20 years until 2000, 14 years after that. So we would substitute the number 34 in for which variable? X. And when we solved it, we would get our y, which represents the what? Y is representing what in this case? Y is representing what? Adesia?
The time, the year.
Not y. The y represents
No, the time.
the amount of time it what?
It took them to complete the race.
Good. The amount of time it takes them to complete the race. Any questions on this? Okay, listen carefully. I need you to clear absolutely everything off your desk except for a pencil. And we need to do this quickly because I need to prepare you for our after lunch activity. Okay. Lead us, let's go. 4, 3, 2, 1. Mouth closed, eyes up front. To get you initiated into our lesson for today, we are going to watch a little, about 2-minute clip of bungee jumping. Okay? Cool. Keep your comments under your breath a little bit so that we can hear what everyone is saying, and then we'll move on. Okay? Keep in mind, excuse me, I'll wait. Keep in mind, we're going to relate this to math. So don't just think about the thrill and the exhilaration. Think about how we might relate this to math and what we're doing. Here we go.
I don't know why. To the child with the smiling photos. Made some decisions, some wrong, some right. Now strangers will my number when I see you at night. Right there, said it's true. And then I was. Don't let me go. Hold me like a baby on the home.
I'll get the straps off, my go, ready to jump. I'm not ready actually, just
I roll away like a penny down a hole in the road.
Okay. So, today, obviously, for liability reasons, I cannot take you bungee jumping, nor would I want to. Okay? But we are going to simulate this using Barbies. Okay? The ultimate goal, time out. The ultimate goal is you want to predict how many rubber bands, because we are going to be using rubber bands instead of bungee cords, okay? You want to predict how many rubber bands, essentially how long will Barbie's cord be, okay, when we drop her tomorrow off of the railing from upstairs to down here, okay? The way that we are going to do that, listen carefully, I know you're excited, stop. The way that we are going to do that is you are going to test it by having different numbers of rubber bands. So we have
James?
1 in this case. Please stop. Stop. Okay, you're gonna have 1 rubber band here, okay, and you'll bungee Barbie, okay, and then you can put 2 on, and you'll bungee Barbie, and you can put 3 or 4 on, and you'll bungee Barbie, and you're recording how far down she comes that initial time, not how she hangs after she stopped bouncing. You want to see that first bounce, how far down she goes. That's what you're measuring, okay? Once you get all these points, when we graph them, what will it make? Raise your hands, please. Once we graph 1 rubber band, she went this far. 2 rubber bands, she went this far. 3 rubber bands, what will that make?
It's like, it's kind of,
A scatter plot, right? We've done that. Okay, and then the scatter plot, eventually our goal is to create a what?
regression.
A live regression, or line of best fit. Good, okay. That line of best fit, like we just did for predicting in the drill, we will predict how many rubber bands we will need to get a certain distance, and the distance I've measured out there, which I'll be giving to you. Okay, so today you're doing testing to see how far down Barbie goes for each rubber band, how far she bungees. Okay, you can use as many or as few rubber bands that are in your bag. I've already set up a table to start you. That way, once you find your line of best fit, you can make a prediction of how many rubber bands you're going to need in order to bungee her from the railing upstairs down here. Here's the catch. Some fellas in my last class was like, I want Barbie's face to smash. And when they bungeed, they're like, I just want her to hit the ground. That's fine, but this is a grade for you. So while Barbie can't really die, your grade can go down the tubes, okay? So it can go down with Barbie, okay? If you predict and Barbie hits her head tomorrow, you lose points on your prediction, okay? So it's kind of a game that you want to make sure you're doing mathematically correct. Just like if you were to go bungee jump, you would want to make sure everyone is accurate as possible so that your cord is not too long and you hit your face.
That's why they wait.
Okay.
That's why they wait.
I know. So that leads me to these 2 questions that I want to ask you, and then we'll distribute our materials, and I will show you 1 demonstration, and then you will be able to investigate on your own.
Wait, are we gonna have groups?
Yes, you are. We'll get this. Okay. First question. 3, 2, 1. Mouth closed. Thank you. That's in front. Raise your hand to answer these. I know some of them may seem obvious to you, but do you think the length of the cord matters, Brett?
Yes.
Why?
Because if it's too long, the Barbies could hit the ground, and if it's too short,
It's not really a thrill, right? Okay. So the cord does matter. What about this one? Would it be smart to lie about your height or weight? And girls, we're kind of famous for this. Boys do too, but girls, you know. Would it be smart in this case to be like, oh yeah, I'm 20 pounds lighter than I really am? What do you think, Jane? Why not? It could make you go down with the rope. Any other thoughts? Steven?
that like when you go down,
It could snap. Okay, so they might not have a strong enough rope to hold your weight that you have. AJ?
You could go down farther than they expected.
Yeah, the cord could should stretch out longer if you're heavier, okay? They have to compute the perfect cord for you so that you are safe. Yes, Kayla?
For the height, you would probably want to because they have to make if you're like really tall, then they have to make the cord a bit shorter so that way your head doesn't
Right. I think I would probably lie a little bit more to the side of, oh, I'm much taller than I am, so that they calculate it and I have more room above my head. But that's just me, okay? Make sure you guys need to put everything in desk because we're going to need a lot of space today. And then you may line up.